G'day there. You're watching the Aussie BIM Guru, and today I'm going to do a quick video where I'm going to show you how to use events and hooks in pyRevit in order to automate events based on what happens in Revit. So unlike typical tools that will run when you tell them to, we're going to use tools that run when Revit tells them to. So in this case, I'll be using Autodesk Revit 2022 and Notepad++, and also pyRevit and IronPython as my programming language. So if you haven't already seen my other pyRevit videos and also my Python 101 series, I do recommend watching these so you are familiar with the fundamentals of both Python programming and also some techniques that we've already used in prior pyRevit videos if you haven't seen them already. So what is a hook? Well, in this case, a hook deals with something called an event. In this case, these are common in programs. Usually it's a program's way of notifying potential routines that something has happened, and this can allow us to actually either intercept or do something based on these. Now, today we're not going to work with a hook that stops things from happening, but I will show you that in a future video. Today, instead, I'm going to focus on a hook that is triggered by a particular event. So we're going to be looking at synchronizing in this case, which is quite an interesting event to detect. So I'm just going to briefly cover types of hooks and then also how we can save and load data, because we're going to be working between two hooks here. One that runs when we begin synchronizing and one that runs when we end synchronizing, and it's going to check how long that synchronization took using a temporary data file that pyRevit can author for us. So without further ado, we'll jump straight in. As always, if I'm talking too fast for you, feel free to slow me down in the playback speed. So to begin with, let's just have a look at hooks in pyRevit. There's a really great section on the Notion board for pyRevit that has a section dealing with types of hooks. So we can see here, for example, we have docsynced and docsyncing. And in this case, we need to call our hook files these for pyRevit to register them as the scripts that run when this event happens. Generally, we're going to be placing our hooks in our toolbar. So in this case, I have a pyRevit folder, an extension, and before we jump into the tab, we can also create hooks in this little folder called hooks. So what I'm going to do is just create a new script, and I'm in this case going to save it to this folder, and I'm going to make this a very particular named file. So in this case, I'm firstly going to be using my doc syncing, because this is going to trigger when we begin synchronizing. So I'm going to change in this case probably to all types, and I'm just going to call this docsyncing.py. And when we refresh our toolbar, pyRevit's going to know that this hook is available and should be run when we begin synchronizing. So let's actually begin setting up this particular tool. So in this case, first of all, we are going to need to import some libraries. In this case, we only need the script library to store data, and we're also going to be using a library that deals with dates and times called datetime. So I'm going to begin by importing some libraries, and I'm also going to say from pyRevit import script, and also from datetime import datetime. So that's the typical way to bring in the datetime object we can work with. Now I actually need to check what the time is at this particular point. So I'm going to use, in this case, a method applied to datetime called now. And this will return a datetime object. But from this, I do need to actually get some pieces of information about the time. Now I could use what's called a datetime delta in this script, but then I would need to pass a datetime object through a data file. Instead, I'm actually probably just going to track it using strings that I can deprocess in the next hook. So in this case, you can use various types of formatting to get pieces of information about the date and the time. And in this case, I'm going to be firstly using the %h, also the %m and the %s, I believe it should be. Yeah, somewhere in here, %s, to get the hours, minutes, and seconds at the time that I synchronized in 24-hour format. So of course, this sync isn't going to work too well if you cross from across midnight, but hopefully no one's working at that time. Otherwise, it might think it's been a very long sync. But what I'm going to do in this case is use a method that we can apply to datetime, which is a string format at time. So I'm going to take my datetime object, and I'm going to use the string format time. And in this case, we're going to use that code as a string. So firstly, we need %h, and I'm just going to put a dash there so that we can break this back up into its components. %s And at this point, we should store hour, minute, and second as a string. The last thing we need to do is actually store this data, in this case to a pickle, I believe it's called. pyRevit does provide us with a tool under script called store data. And in this case, what this will do is store a particular piece of information that we can retrieve later on using a key. In this case, it becomes a file name. And in this case, we will say this project equals true, because it will be for this specific project we're synchronizing in, but you can also work across project using these data files as well. Let's say you've got a set of hooks that activate when you change from one document to another. Well, in that case, you would need your data storage to work cross-file. But in this case, I'm just going to copy this piece of information. Now we are going to do a try and accept just in case this area of the computer isn't available or something goes wrong. But we are going to try to write the data. So in this case, I'm just going to say try, and we're going to try in this case to store some data. So in this case, I'm going to call the slot name sync start, and the data in this case is going to be formatted datetime. And this project will equal to true. And of course, if it fails, we'll just pass. So we won't actually see anything happen on the surface in Revit, but behind the scenes, this hook should go and store some information for us. And in this case, it should be stored in a folder. Generally, these files will be stored on your roaming data folders under pyRevit and the version of Revit you're working in. So if you are using pyRevit cross-version, just be mindful these data files won't always work cross-version, so you need to be careful if you are working with some of these that need to span different builds. But in this case, we're just working in a single version for a single sync. So in this case, I'm actually in a central file. I'm just going to reopen it as a local, and this will give me the ability to synchronize this model. Now I also need to reload my toolbar because my hook currently won't have been picked up by pyRevit. So under pyRevit settings, I'm just going to save settings and reload. And you won't see hooks in your toolbar. They're behind the scenes in your extension, which holds your toolbar and all the components that come with it together. So the hook should now be available. So if I begin to synchronize, we should expect our hook to be detected and our file to be written. And there it is. We can see it's sync start test, and we can see the name of the document. And if I open this particular file, we should find it just contains that date time object that I've created. Sure enough, there it is, 9:43:28 seconds. So now we need our second hook, which it's going to go and retrieve that data and then check against the current time how much time has passed. So in this case, we're going to need to use another hook in this case. And we're going to be using, in this case, the doc synced event. So when a synchronize has completed. And assuming we're the same user, we know that starting and finishing a sync should always be events that follow each other, because Revit is idle during that process and we can't actually interact with it. So what we're going to do in this case, I'm just going to take my doc syncing hook and I'm going to just change it to doc synced, because these hooks aren't too different in structure. In this case, we do need one additional library. Actually, we need two, because we're going to give a notification to Windows to give us a little notification when we finish synchronizing. So in this case, I'm going to be using what's called a toast form, which will actually send a message through Windows 10 to us, like a notification. So it will sit above Revit and other programs, and that way it's not an annoying little pop-up in Revit that forces you to hit OK. So it's a much more easy sort of notification to deal with. So to begin with, we're also going to get the time again, and we're going to do it in the same format. In this case, I might actually say format 2. And what I'm going to do now is I'm going to try to get the data that we stored. So in this case, I'm going to try to get data. And probably what we will need to do eventually is put this next step underneath an entire try and accept, or make sure that if there's no data received, maybe we can cancel our script. So what I'm going to do is try to get the data, because remember, maybe this data doesn't exist yet. It should in principle, because you can't have synced without starting to sync. But in this case, maybe we didn't manage to write that file. So I'm going to go and retrieve this data and store it to datetime format 1. So in this case, we're going to use a similar format to before, but now we're going to use the load data script method. And I'm going to be calling on that same key that we stored this to. This time I don't need to write any data, so from here I can just say that this project is equal to true. And if we do have data stored, we should receive that formatted datetime object. And if we don't, then I know at that point I can exit my script, and the script will not run from that point onward. And what we're going to be doing now instead is trying to break down this data into parts that we can actually work with. So the first thing I need to do is break down my date format string into its 3 components. So I'm going to break down, in this case, the data. So I'm going to say before is equal to the format 1. And I'm going to be using the split method here, using a delimiter of a dash. And this will break our datetime into those 3 pieces, because I've used this separator, and it's going to return this in 3 strings in a list. So in this case, we can use that. And then I also need to say after is datetime format 2 split, and I'm going to be doing the same thing. In this case, what we might also do is maybe we'll just make a message and try to create by adding to this message. So you'll see what I mean in a second there, but I'll say for now message is a string. And this is going to be the notification that we try to send through Windows to the user. What we want to do now is find out how many seconds have passed, and then we'll break that down into minutes and seconds as well, hopefully not hours. So to do this, I'm going to use a function to check seconds in time. Now there's probably a more direct way to do this, but I'll use a fairly straightforward approach here. So I'm going to make a function. I'm just going to call it getSeconds from a list object. So I'm going to call the variable in my function LST, because we know it's going to be 3 objects. So I'm firstly going to say h for hours is going to be equal to the first object. And this is currently a string, so we also need to convert it into an integer. And from there, we're going to be multiplying this by 60 minutes by 60 seconds. I can then say minutes is going to be the same, but the second object in the list, and this is in minutes, so we multiply it by 60 to get to 60 seconds. And finally, the seconds we know are already in seconds, so we just need to get the objects. Finally, we can return all of these together to get the total number of seconds at the point where we synchronized and at the point where our synchronization finished. Now we haven't used this yet, but this is a function we're going to use at the end to calculate the difference. As well as this, I might just go straight now to just trying to actually check how much time has elapsed. So I'm just going to do this again in a try and accept. Try to report the time difference. So I'm just going to say that I'm going to try, in this case, to firstly say what is the difference in seconds between when I started and when I finished. So I'm going to say that I'm going to call this elapsed. I'm going to say this is equal to getSeconds, my function I just made, for after, minus getSeconds for before. And we know that the result should be the number of seconds that have elapsed. Now we're going to break that down into minutes and seconds. So first of all, we need to figure out how many minutes have elapsed. So we actually need to use another library for this called math, so that we can round down to find out how many minutes we actually have. So I'm going to say in this case, mins is equal to, and I'm going to use the math library.floor, and I'm going to get the floor for the elapsed difference divided by 60. So what this will do is if we have, say, more than 1 minute, then obviously we would have 60 seconds plus a certain number of seconds, and this would round it down to 1 minute. So we're going to get the whole number of minutes that have elapsed. As well as this, I can say the number of seconds in this case is going to be whatever's left after we do that. And we can use an operator in Python called, in this case, modulo, which will give us the remainder of dividing this object by that number. So if it's, say, 20 seconds, then the remainder of the time divided by 60 is still going to be 20 seconds. So this way we can get both before and after our particular time. If I wanted to, I could also assess how fast that time was and maybe track and report it. Say if someone does more than a 5-minute sync, maybe I wanted to send me an email to report that there might be a problem. So we could do a lot of things with that. But for now, I just want to send this time back to the user. So I'll say in this case, maybe we actually want to make this time into a string. That would probably make sense. So I might actually make a function to convert this into a string. And in this case, what I did find out when I was building this initially is that I do have to do a few things to this string because it does come back in a non-ideal format. So first of all, I'm going to convert time to string. So I'm going to call my function that, and I'm just going to be sending in a piece of information, in this case, a string. So the first thing I am going to need to do is when I turn this object into a string, it's generally going to add a trailing decimal point to this object. So I am going to want to get rid of anything after that when it comes to the minutes. So I'm going to say in this case that I want to take this object and I want to first of all turn it into a string. But then from that point, I also want to split it if I do end up with a decimal point. And from that, I'm also going to want to actually take the first piece of that split outcome to get the number up to the point if it happens to go that way. In this case, I'll just say that this is unpadded because we also want to pad this to two figures. So if we have 2 minutes, we want it to say 02. If we have say 6 seconds, I want it to say 06. So in this case, I'm going to return, in this case, that object unpadded, but I'm going to use the rjust method, which is a padding method, which will go, in this case, from the left. And in this case, I'm going to say I want this to be 2 figures, and I want to pad it with the character or the string character 0. And this will convert my integer or my time that I've got for minutes or seconds into a well-formatted string. So now I can actually form a message to the user. And in this case, my message, I probably don't really need to add to the message. I probably don't actually need this because I've got try and accept. I'm going to say message is equal to, and I'm going to use time to string on minutes. I'm going to say plus m. And I'm then also going to do time to string on my seconds. So I think I should have, yep, secs. Not the best word. And then I'm just going to add secs on the end. So I say minutes plus seconds. And now at this point, now that I have this object, hopefully, I'm going to send this to Windows. Send this to Windows. So assuming all of this works, we should see a notification. So in this case, I'm going to use that toaster, and I'm going to use the send toast method to send this notification to Windows. So firstly, you want to see our message, then we need a name for our message. So I'll say the title is equal to sync completed. And in this case, there's a few arguments that we want to specify with no information. So there should be a send toast. I believe it's this one here. There we go. I don't want get toaster, I want send toaster. Here we go, send toast. So in this case, I don't need an app ID, an icon, a click, or an action. If you did want to give it a custom icon, you could. But in this case, I'm just going to say these are all equal to none. I'm not sure if they're optional arguments. I'll just put them in there anyway. And if for some reason we haven't managed to get that part of our script to work, I'm just going to say for accept, nothing happens. The sync isn't reported to the user. Now again, we've got 2 hooks now, so I do need to refresh my toolbar. But we should hopefully get both the first part and the second part of the workflow working together now. And also by using that parsing of data, we should be able to track both the time before and after, and then the final hook will report that as a little toast notification. Now hopefully the toast notification comes to my primary screen. I do have a secondary screen, if so I may have to potentially just assure you it works, or maybe switch my screen. But in this case, if I do a synchronize, we do know our first hook was definitely working, so our second hook should hopefully now come at the end when we finish syncing. So it's currently syncing, it's just finished syncing, and in classic fashion, something hasn't worked. So what I'm going to do is probably just for now, I'm just going to take the try out and just see what might not be working there. So this is a little trick in Python a lot of people use. It's sort of called commenting out lines. If you want to take a bit of code you're going to put back in eventually, you can just turn it into a temporary comment. So with this for now, hopefully we should see our secondary hook activate, and we'll get an error telling us what's wrong. So in this case, forms is not defined. So have I not loaded in forms? Yeah, I didn't load in forms. Okay, so that's a pretty small one. So because I used a form, obviously I need the forms namespace available. So let's try that again. Hopefully that's the only thing that's wrong. There we go. And we can see that our synchronization was completed in 3 seconds. So it's a great way to make the user more aware of if their sync is taking too long or if something's wrong. Say if your sync goes for 2 minutes, maybe you might make it say something different. Instead of sync completed, you might say slow sync, or you might make it pop up a user message or something a little bit more aggressive to make the user more conscious of maybe a model that's not in very good health. But just to recap, effectively all that needed was these two Python scripts stored in the hooks folder for your toolbar that's loaded for the user. And in this case, we have, first of all, a very basic hook. So we have doc synced and doc syncing. So I'll just go find doc syncing. So doc syncing just gets the time, stores it as data, and then doc synced comes afterwards and instead retrieves the data that we already stored, and then formats the data, breaks it down into seconds, calculates that into minutes and seconds as a difference, which I know you can do with the date time delta as well, if you want to look into that. And then from there formats a little message and sends it to Windows in the form of a toast message. So now I can actually recomment, so decomment those lines, just to make sure that my script is actually safe. And there we go. So we now have a very functional, cool little set of hooks. Now there's a lot of different types of hooks you can use if you want to that pick up a variety of events. There's a really good list of them over on the pyRevit Notion board. Be aware some hooks happen quite a lot. So for example, progress change to even notes, be careful. This is actually a pretty aggressive hook that happens quite a lot. Things like view activated, view activating, you can pick up when you enter a view, for example. But do be careful that you don't use something that fires all the time, because your script might potentially lag you quite a lot depending on how heavy it is. These scripts are quite light, and synchronizing is a pretty slow thing usually, but you may have trouble if you use a more frequent event that can happen more often. So you'll be able to find this and other tools over on my GitHub, and I hope you found this an interesting tutorial about pyRevit. Thank you for watching, and feel free to contact me either via email or in the comments if you have any queries, or if you just have a video request or want to share your thoughts. And I look forward to seeing you in future similar videos. Thanks. Take care. Bye.